All right, well, welcome. Thank you for joining today. Basically, this is the week one of our 4-week R Beginners Bootcamp workshop. The goal is to provide you with just a basic foundation. So when we move on to further skills, you'll be able to have that foundational knowledge to move on and learn more to be able to apply R. Now, I don't expect anything from you today. Today is just a completely beginner, so I want to start from really scratch and just give you an understanding of how R works, the data structures, how things fit together. And then I think we'll be able to move on in the coming weeks and really give you that real basic knowledge to keep you move forward. Now, how am I going to be presenting this? Well, several different ways. We're going to have these HTML files here that are on the right. You can see how they're structured here by different hierarchies of the directory. You can move up and down and see. And this just gives you a great understanding, a great ability for me to outline what we're going over. And what we're basically going to see here is we have these shaded areas where we have actually the code, and then we have these kind of white areas right under where we have like the application of the code. But where is this coming from, right? So this is our studio, and this is basically the environment that we use, the predominant way to be able to edit code and run R. It just makes it a heck of a lot easier. And here, basically, I have this R markdown file, this .rmd file, where I have outlined. You can see here is the same thing you see in here. And what I've done is I basically outlined the different types of code. I mean, I've basically outlined the different introductions, and you see here in these shaded areas you have the actual code, and when I run that, it's seen. You can see it over in the HTML file. And if you want, you can also follow along in these RMD files, and basically what you can do, you can run any code you want at a time. You can do like by run a selected line, you can see here, or you can also click along with this green arrow, and it'll run all the code here. And you see this is what we're seeing here. So you're not really missing anything by using either method. They kind of complement each other. But I just want to kind of give you an idea of where this stuff is actually coming from. Now, also, like, R is not necessarily, you don't have to run R from this R Studio. You can, R is really a terminal language. So you can pull up your terminal, your command line, and just type in R, and you will see, look, you see that we have exactly the same thing as we see here. We can do this 2 + 2, we can do this, get the same answer here, right? This is just a way here of projecting this terminal inside this RStudio IDE, which gives us a great ability to work with things a lot easier. I mean, if you're working in here, where are your variables, where are your code, much harder to use. So we'll go ahead and close that, and we'll work just from here, moving on. All right, so first I want to talk a little bit more about this RStudio interface. So if you go down to here, so basically there are 4 main panels you see here in this RStudio IDE. You have your script editor in the top left. This is where we have our basic code. If you want to start a code, we'll be working with extra code here. You go to File, New File, R Script, and this is where we can type in some code as we go. And we kind of just organize everything and be able to basically visualize it. Otherwise, it's really hard to know what's going on, right? So your bottom left is your console, which basically you can run interactive commands. We talked about this is the command line basically put into the IDE. The top right is your environment, your history. You can see here if I assign like a variable, we'll talk about this later. Anyway, you have your basic global environment of your values, data frames, things like that. And we'll get to those a little bit later, and it'll become obvious. And the bottom right is basically your files, your plots, packages. Basically, it's a combination of your directories and also your different plots you'll run here, different packages you have installed here. And it's just a way of seeing all that and organizing all that there. So let's go back to the HTML file and kind of start going through some of the basic things. So your very first R commands, hello world, right? Hello world. Well, we'll do hello TMP instead, right? So if you see here, this is basically a function. You see print, and whenever you have a word like print here, and you have parentheses, you know that you have a function that you have an input for. So basically this is a character vector. We won't talk too much about it, but this is a character string, putting it inside running print. And this is basically how the R functions are built. So you can imagine there's a lot of code that goes behind this print term, right? This print function is built and it is found in just base R, so you load up R, it's just there. So it's just a way of organizing your code into a function, and then you can put in a string in there and run it, and you get an answer. So that's part of what R is built on, are all these basic functions that you write the code for and string together. R can be used as a simple calculator, and this will come in handy later, you'll see, but you can just do, obviously 2 plus 2 equals 4, you can just multiply numbers, and once you have variables and matrices and stuff, you can perform actions on them very simply like this. So it's just good to know that you'll be able to do this. So what are R packages? So before going further, I want to talk about more about these packages are. So I mentioned the functions, right? Well, let's just look at one simple package, ggplot2 here, right? So ggplot2 is a tidyverse package. You're probably familiar with it, at least the name of it, for plotting things. And so basically, think of a package as just a lot of functions. So a lot of code goes into little tiny functions, and then they're packaged, they're put into a big package, right? Library package, kind of interchangeable words. And then when you can install this package, you get all those functions. You're able to use those, and you're going to be able, so then you pull in bioinformatic functions, statistics functions. Anybody who writes functions, you can write your own function and pull it in and be able to call it, right? And to install multiple packages, you can just, you can have commas here and just kind of see to combine the different things. I usually do one at a time. Another really easy way to install a package is, I'll show you the easy way and the right way as we go on. You can click on packages here, install, and ggplot2, you see there, it's from the repository CRAN. You can install it there. It basically just runs the exact same functions. There's really no difference in doing this either way. It's just whatever's easier for you. I think it's better to hard code these things. It just becomes simpler to pull in these things, especially if people have it on a new computer. It's much easier just to run these things than having to go click on, each part of the RStudio, right? So that's the way you want to install a package, right? So, and I mentioned CRAN, right? So most packages are in CRAN. By 90% of them, 75%, let's say. So people make a package, they send it up to CRAN, CRAN puts it in their library, or they're called repository, and you'll be able to pull it down from CRAN. But not everything's in there, right? So a lot of things that are very cutting edge, just been developed, they'll be on the developer's GitHub. So in that case, you want to be able to install this DevTool package first, and then run this command, DevTools install GitHub, and oops. Sure what happened there. And then we'll be able to basically install the basic patches from the GitHub. And there'll usually be like some simple instructions of how to do that there. And so these are the 3 of the main ways you can install. The 4th, and this comes in a lot, is this bioconductor. Bioconductor is basically a repository of all these functions. Let's check it out. Bioconductor there. This is basically a bioinformatic repository of all sorts of different packages and functions. Like, for example, let's check out like complex heat map. Complex heat map is something that is used for plotting. Very, 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 very important. If you click on complex heat map, so this wouldn't be found in CRAN. That installed out packages would not work for this. You would need to go actually to this bioconductor. And you see this is exactly what I showed you here. You can just pull this and run it, and it would install complex heat map. And once you install the biomanager one time, you would only need to run this bottom command, this biocmanager install, and it would run to install the packages. So I would say that 90% of the time or 95% of the time, if something's not installing this way on CRAN, it's because it's in biomanager, especially if you're a bioinformatician and you're running across those kind of packages, right? So that's the way to install that. And so once you install the package like into your library in R, you need to be able to load this. Each session, each time you run through R, you need to actually load the packages from your library. So you do this by running this library command, and basically what it's saying is you want to go into your library on your computer and find ggplot2 and load it into your session. You can also use require, but library is the main way that everyone does it. So you basically install a package, and then you call the library, and usually you'll see libraries, these terms of all the packages you need up at the top of a script when you're just starting the script to be able to get everything to move forward, right? A couple of essential commands, just kind of being able to navigate and check for packages. If you just want to see if the package is installed, I mean, one way you could do it is to go to RStudio packages and search here, ggplot, is it there? If it's in this list, then it's there. You can also run this command here, which basically is saying is ggplot2 in the row names of all the installed packages, right? It'll give you a yes or no. You can use this to list all your packages. You can do this this help to package, and now you can do this line, this update.packages to update. But I would never use this update all packages. So you have hundreds and hundreds of packages on R, so you never want to update all of them because you could change the versions of some and they wouldn't work together after that. So you want to do those in groups. When you install a new package, they'll often ask you, do you want to update this or that package? Then you can do it in there. So don't ever worry about running that. If you want to remove a package, you can do it through there, or you can delete it through the RStudio package. But you rarely remove packages. That usually happens if you need to remove and then add back a different version. So don't worry about that. What are some common issues that happen with packages, right? Well, the package is not found after you've already installed it. Well, that's because you haven't run the library. You have the package on your computer, but you haven't pulled it from your library into the session. So run your library command, right? Not available for this version of R. That happens a lot. You maybe need to update your R version, or maybe lower the R version, or find a compatible package version, a different package. Sometimes you're able to install, if you need to install a specific version, you can install an older version. And there's ways to do that, usually found in the documentation of the relevant package. If you get any kind of permission errors, this is usually a MD Anderson problem. It could be a problem on other computers where you're not the administrator, so you may need to ask for administrator or relog in as administrator to be able to run, to add to install your libraries at the beginning. The package version not found in CRAN. Well, this is what we talked about with the GitHub or Bioconductor. If it's not in CRAN, it's most likely in Bioconductor, if not that, in GitHub. And one more way you can get help on functions, so this is to get help with packages, right? Just another way of getting help with a function, you can do a question mark in the very middle of it, or help. So help function, or help a certain exact package to get help. But I would never use these in our help things. I would always go to Stack Overflow or Google or the developers page or ChatGPT. You're going to get much more robust, much more comprehensive answers there. It'll be a lot easier to read. So if you need help with solving these things, Google it, ChatGPT it. It's a problem that probably 1,000 people have had before you. Every problem you have in R has happened before, I guarantee, and someone else will be talking about it. Hundreds of people will be talking about it, minimum. So you can get those things. So now we kind of understand what R is basically as a programming language, how it can be run in the terminal or in RStudio, and we've seen the RStudio ID and how useful that is, and our ability to install, load packages. Okay, so we're kind of rolling, we're moving along, we can get things going, we got our session going. So let's move into just our basic data types in R, right? There's several data types in R. These are the three main ones, I would say. The numeric, the character, and the logical. And the numeric is just a number. So 42, 3.14, whatever. You basically can assign these. So the way you assign variables in R, or assign to anything in R, is this arrow figure, which is just the less-than sign and a little bar there, the horizontal bar. And what you do is you're basically assigning this number to this variable. Let's go in R. You will often see this. I'm basically just copying and pasting. Get used to this because you will do it all the time on the tutorials and our help pages, everything. It's very common just to jump back and forth, right? So let's go and install that. Let's go ahead and drop that in. My number equals 42. So basically, I have assigned 42 to my number, right? So if I pull up my number again, and just run that alone, then I'll get the 42, right? So just the variables have been, 42 has been assigned to my number, okay? Same with this one. So these are numeric values, they're numbers, right? So what about text? You do kind of the same thing, except you put the actual text in either double brackets or single brackets. I like to use double brackets, it's more common, but either way it works. And spaces don't matter when you're inside brackets. They'll be preserved. So same deal with this guy. We can run this one, and now my name, our programmer is pulled into the variable my name. So now we have a character variable as well too, right? We can also do this with logical values. So logicals are basically a level. We'll talk more about different levels later on because you can have multiple levels, infinite number of levels really. But that's for another day. It's a little more complicated. I want to stick with just looking at the binary 2-level logical variable, where you're basically doing true or false, and you can just assign that same thing. So is it fun, true, is it difficult, false? So you can assign any variable to logic or true and pass those on to annotate different other variables, right? So how do we know once we have a variable? We want to use this class function basically to see what kind we have. Let's say we didn't know what kind we have, right? What is my number? We have a 9 number, we don't know what it is, right? Well, here we go. It's numeric, right? And if we do class my name, and you'll see too, if you just kind of start filling it out, R will give you the different options. So let's we'll try that, and now we're seeing it's a character, right? So we can use the class to figure out, be able to tell us if it's what kind of data type is it, right? And that becomes very useful because later on, when you start getting into this, it'll really matter. Like functions won't work unless they have the proper data type, all right? So now we kind of know our basic data types. Let's go back and just kind of talk about variables for a second again. When we did the my number equals 2 or whatever, just a reminder that we use this arrow basically to assign. It's not just for a variable, but it's for anything, for a list, for a data frame, for anything, as we'll see. You can also use equal, but you'll never see it used. So I suggest using that. It's cooler, and it's what you're going to see everywhere. And you also can for operations with variables. You can stack together several variables. You see here they've just added all these together and assigned. Here's an example of assigning it to another variable where it's not just a number or a character. You can do an operation and assign the result to that, or advantageously to results, right? And run that to get it. It's just adding those together, right? Also, be really careful. Everyone tells you this with programming, but since we're doing a very beginner's class in programming, have your variable names be very descriptive. So don't just be like age, be student age. So when you look at this 6 months later and you pull up this code and you don't remember any of it, you'll be able to look at these and understand what the heck you're doing. So just a good peace of mind there. Okay, so now we know kind of how R works, how it can fit in our studio. We kind of assign variables. We have some data types. Now let's get into vectors. Now I will say that understanding vectors in R is the most important concept. And it seems really simple and obvious, but even going over this again with you today, I'm understanding it better after working with R for years. That all R is working with vectors and forming operations on vectors. You basically have vectors, you stick them together all different weird ways, and you stick them in functions that are, and you get answers. That's what R is. And the ability to work with vectors is this thing that basically what optimizes R to be the fastest way to work with tabular data, faster than Python, Excel, or anything else. That's what makes it so powerful, is its ability to work with vectors. So that's why we're really trying to take it slow and understand what a vector is and how it's used. So what is a vector in this at all, right? A vector is just a sequential number of elements, right? If you can think of just 1, 2, 3, 4, 5, just think of a line, right? A vector. Like remember, when you studied physics and they gave you a force vector, where the force went in a direction. I like to think of it a direction and seeing it visually. So you can kind of see this vector shoot out to the right here, 1 to 5, right? And the way basically to build a vector is you have the C command, right? C for combine in parentheses, and then just run your numbers, whatever they need to be. So it's 1 to 5 here. We call it back. That's our vector. We can also create a sequence by using a colon here, like 1 to 10. We could have said 5 to 10. It would have given us this. And we're basically just getting a vector in that sequence. You can also, another way you can do it, just if you want to make a sequence, use the sequence command and do your start stop from 2 to 20 by, how much do you want to go by? Here it's by 2s, right? And this is a good way to make like synthetic data, and which does come up fairly often, and it's important to do as well. Okay, so also rep is a really cool way. I use rep a lot actually. So rep is just repeating, right? So we're repping 105 times, right? So this is very useful actually. A lot of times when you're naming things and you need to name 1,000 things, you can rep different things and add them together or combine them. Or if you want to get a result that always goes in tens, you can rep 10 times each variable. It's actually very, very useful. And this is a very simple example, but keep in mind that actually I've never used sync before, but I use rep all the time. So far you've seen numerical vectors, right? Well, what about character vectors? Same exact thing, right? C combine, parentheses, and then our characters. This time, obviously they need to be in double quotes. But now we have, apple, banana, orange, grape. We call that vector. You see it across here. Same exact thing as before with the numerical ones, right? How about logical vectors? Same thing. C combine, parentheses, and then here we have true, true, false, true. And you can imagine if we combine these vectors together, it'd basically be saying true apple, true banana. There's just a way you can, one way you can use these logical vectors to be of use. You can call it back again, you see that, and that's just a way of, that's how we make our vectors. They're simple linear vectors, right? Just think of the vector one again. It goes left to right, up and down. And then what's cool is, remember I told you all R is making vectors and doing things to them. Well, if you have a vector, you can perform simple operations on them. You can just make the vector and just multiply it by 2. You see each value here has been multiplied by 2. 10 has been added to it here. They've been squared. They've subtracted here. They've been multiplied. So once you have these vectors, you can perform any kind of operation, simple to hard, that you want to. You can imagine how useful that could be. So the next step is indexing and subsetting these vectors. So once we actually have these vectors, what if we want one value of them? Or we want a couple of values of them? How are we able to subset these out? Okay, so the way you do this is by brackets. If you have a parentheses, it's more for a function or creating a vector, where brackets are going to be more always for subsetting. And basically R uses 1-based indexing, so the 1 is the first one, as opposed to Python where 0 is 1, which makes it always very confusing. So it's a lot simpler with R, where it's just 1 equals 1. So we put in 1, and we get the first element, right? Apple. We put in 3, we get the third element. And if you want to, and think about these as being vectors. We're always working with vectors, even if it doesn't look like it. Even though you have one number here, this is a vector. You're putting in a vector of length 1. A vector of 3, length 1, right? So here you can imagine, what if we want to see 3 things? Well, we make a vector, right? C combine parentheses 1, 3, 5. So we made a vector of the first, third, and fifth elements. We put them in the brackets. We call it, we get back 1, 3, 5. So that's why you have to, you can't just put 1, 3, 5. You need to have a actual vector here whenever it's, so if you have multiple values, you always need that C to combine them. One exception is when you're doing the sequence, where you can do like a 2:4. That's basically giving you that vector as well. So you're putting that vector in and getting it back. Conversely, if you want to take out, if you want to use the negative one, let's say you want all values but the first one. Well, you say -1, I don't want 1, I want everything but 1. Here, I want everything but 2 and 4, right? And you can also do logical indexing. If you just call the variable on, and you make it binary, like greater than or less than, which is our binary logical variable, and a value, then it'll give you like a true false across the vector. So 10 is not greater than 30. 25 is not greater than 30. 30 is not greater than 30. 45 and 50 are. That's why you see true here. But if you want to call them, once again, you have the brackets, and this is a vector then of these two values. You put them in, and you get 45 and 50. So the idea is you can use these brackets basically and the position in order to grab out the part of the vector that you actually want, which is very important. Very important. Indexing and things like this is useful all the time. So it's very important to understand how to do this. And then vector functions, how do we run a function? We told you that once you have vectors, you're going to run all this stuff on them, right? Well, just a very, very simplistic value. We've made this number vector here, and we're just running some of these very R basic statistics functions, like length, sum, mean, median. You guys know what this means. And basically, we're just getting a value on the vector. So we put in a vector in here, length's 10, sum is 592, means 59.2. So the idea is you can just put any kind of vector into a function to be able to get the actual result. And that's the best way to be able to deal with that. Well, this is a very simple way of dealing with it, right? But this is going to become more and more complex as you learn more. And there's more to it: min, max, range, sort, reverse, things like that. Find the unique values, all sorts of things like that. It's all putting vectors inside functions. These are just very simple functions, right? Okay, so now we kind of understand R itself, some basic data structures, and how a vector works, and how do we subset vectors. Okay, well, that's just a very, very simple way of having the very, 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 very basics of R. So now, like, how do we work with these vectors and put them together to make more complex structures? So we're going to go over the 3 most important data structures here. I'll go a little bit slower here to really get you to understand these, because these you're going to work with this every day working with R. They're just extremely important. But you can understand they're not hard to work with once you see how they're put together. So first, we're going to go over lists. Now, a list is just a list of things, right? We have a grocery list. We put, some hamburger meat, some cucumbers, some lettuce, whatever, into our grocery chart, right? Into our grocery chart, into our grocery cart. So this could be our list of things we're getting, right? It's basically just a list of vectors. Everything's vectors, right? So it's a list of vectors. So in order to build this list, you can see here we use this term list, and we like always, we assign it a name. So my list assigned by our arrow, and the list command basically makes a list, right? And then we just have basically all our vectors that we want to have in the list. So first we have name equals John. This is a vector called name with 1 value of John, as opposed to scores is another vector named scores with 3 values in it, right? So we have name, age, scores, and past. A list of vectors, basically. And when we call this list, you see, we are able to see how everything's put together and structured, right? And one cool thing about lists and data frames is this $sign. I love this $sign. It's a cool variable, or it's a cool function to use, and it's used all throughout R, and it's very powerful. So basically, what you do is you basically call the list. So you have my list, right? That's the name of the list. You call one of these vectors by the $sign name, right? So $sign name gave us the first vector. What we also could do is subset. So before we have the bracket subset, we would put, if we had a linear vector, it was like 1, 2, 3, 4, 5, correct? This is the same way, except we need another bracket here for this term. So we have double brackets here, and this will give us 1, 2, 3, 4, basically. I have a 1 here, so it gives me John. It's another way we can index it through $sign. If I was indexing just vectors here, just these big vectors, I would always use $sign. It's much simpler to use. And you'll see why later, but I would always call these things by $sign. We could also do it by age. Instead of saying $age or double bracket 2, we could also say age, right? But how do we subset? One question is, how do we subset this guy, right? Well, let's go ahead and build this list in our studio ourselves here. And one thing you can do is you can just shade the ones you need to run and just run that function. And we'll see on the right in our data, once we have a list, we have, the variables are all under here, and our values, data, like matrices, lists are up here. And we can click on that. It pulls up a little window here, and we're able to see, our 4 vectors here and our values for each vector. So it's very easy. It's one thing that RStudio is good for, is being able to visualize this type of stuff. Okay, so basically one cool thing about R, as you start going along, it'll finish the things for you. So it gives you a way of pulling up these values. And second, if you pull up the $sign, it'll give you all the things that are vectors under that list, right? So once again, if you want to use $, we want to call scores, right? That gives us all the scores. So what if I want 90? What if I want the middle one? What would I do there? Well, then I would do subset there, like that, right? because this is a vector. I've already called that vector, the $$ scores. We have that vector, right? So this is we just want to subset a vector. How do we subset vectors? Just brackets the number, just like before, right? That's why I'm saying it's better to not use the double brackets. It's just confusing. Call the big names, the top vectors, by the $, and then once you have that vector, then just subset the number it's in to get it back. Much easier, I think, than messing with that double bracket nonsense, right? One other additional thing you can have that complicates things a little bit are these lists of lists. And you can have lists of lists of lists of lists, and it becomes very, very, very scary sometimes working with it. And you'll often see this when people give you data. It'll be under all these different just crazy levels that you'll have to pull out and access. So it seems more complicated than it is. If you look at here, we just have a list of a list, okay? So we have the list command. Just don't look at this stuff. Just list command, student 1, student 2. So here's our student 1, here's our student 2. These are our two parts of the list, right? And then inside student 1, respectively, we have another list command where we have our vectors Alice and grade 85, right? So we see student name Alice, student grade 85, and basically same thing with this. So you basically have you have a list of students, and within each student you have a list of names and grades. And once again, to access this stuff, extremely similar, right? We have our nested list here, which you see here. Now we have the different parts of the list. We have to open these guys up to see. So we have our list and our nested list inside, right? And if we wanted to look at them again, remember student 1, student 2, let's pull up just student 1. And then, so now we have a nested list of, we have our values student 1. If we wanted to now grab name or grade, let's say we wanted to look at grade now. Well, what's this? How do we do that? We have our vector, right? Well, we need to call in and look at our second value, right? And now we see that it pulled in grade, right? So now we have all our values. And if you wanted to look, if you had another one thing, if there was multiple values there, you would just do it again, like 3 to get the third value. Because remember, these are all lists. These are all vectors. That's a vector. That's a vector. So you just keep subsetting it all the way, along the way you need to be able to get to it, right? But so that's kind of that's basically how lists go together, which are definitely a very important data structure in R. So second, we're doing matrices. So we're going to do matrices, then data frames. The difference between a matrix and a data frame is a matrix can only have one type of data type. So you have to be all numeric, all character, all logical, all factor, same data type. For a data frame, you can have multiple pieces of data in it. And you can kind of think about the pros and cons of both those. While we often use numbers in bioinformatics, we can use a matrix. And we can still have row names in a matrix. So our character values would be observations of row names instead. But I pretty much always use data frames, but you can use matrices as well for numeric calculations. This is just a function here that creates matrices. If you need synthetic data, basically you just run matrix. How many numbers do I need? How many rows? How many columns here? And this kind of created this matrix for us to play around with. Another way you can make a matrix, think about what matrix is. And this is an important concept to think of, I think. It's just vectors, right? It's just 3 row vectors or 3 column vectors. That's all it is. It just depends on how you want to visualize it. So if you think about it, you could just combine 3 row vectors. So you have a row vector of 1, 2, 3, 4, 5, 6, and 7, and 9, respectively, right? Let's say I just want to combine these. Well, I can use a command called row bind, and just basically combines all the rows in the same order you put them. So row bind, row 1, 2, 3, as I've defined, call the matrix, and then just stack them on top of each other. And it didn't sort them or anything, it just stacked them in the way they were. They just happened to already be in order, right? So now we have, just think of horizontal vectors, 1, 2, 3, 4, 5, 6. So horizontal vectors have been stuck together to actually make an actual matrix. And you could do the same thing with column vectors, right? So why can't it just be columns? Think of a column straight up or a vector straight down. So you want column 1, column 2, column 3. It's just 3 vertical vectors put together. And actually, that's the better way of thinking about it, because you normally think of the columns as being features. If you think of just you probably learned this in the past, like with data science. Anytime you're using a matrix or data frame, Excel sheet, you always want to have, just at the beginning, as reference, as a base case, you want your rows to be observations, your columns to be features. So each of your columns will be basically features that are attributes of each row, which is the observation, right? So matrices really are really just combining columns together to form matrices. So you see 1, 2, 3 goes down, 4, 5, 6 goes down, 7, 8, 9 goes down. I've just bound them together, right, to make those matrices. And what about accessing different elements of the matrix? Subsetting. It's exactly the same as we did before. Let's say we're looking for this value 4. Okay. First, we want to know so when you look at this kind of thing, we want to look at the rows on the left, comma, columns on the right. So it's always row, column. But just think of it first as the rows, right? So the rows would be these values, the rows, right? So these are the rows, 4, 5, 6. Well, what value, if I want 4, which value of the rows do I need? 1, right? So you put a 1 there. What about columns? Well, these are the column values, right? Well, what would I put there if I wanted the column value? We're already in this row, we're 1, 2. So I'm basically just looking at the row vector, picking 1, looking at the column vector, pick 2 is kind of backwards, but you know what I'm talking about. And that is able to get us our elements. It's exactly the same as before. There's no difference. And that's conceptually how I want you to think about it. But just for the ease of it, it's really easy just to be like, I want 5. Well, what row is that in? Well, 1, 2. And what column is it in? 1, 2. So it's 2, 2. So matrix 3, 2, 2 will give us 5. That's the simple way of looking at it. But think about the concept of how it's just vectors, and we're subsetting them just like before, no different. What if I want all of a column or all of a row? Well, I basically would say, what row do I want? I want the second row, and I want all the columns. So I don't need to subset columns if I want them all, right? So that just gives me all of that. Same with if I want all of column 3. I want column 3, and I want all the rows, so I don't subset, and I get 7, 8, 9. That's how we're able to subset our vectors. All right, so now data frames, the most important structure. So data frame is by far the most important structure I'll work with. I use it basically every day. 99% of the things I work with are put in data frames. All R is, once again, is putting vectors into data frames and running functions on them. Once you have the cleaned, proper data frame, then all you're doing is just running functions on them. So the skill in R, the difficulty in R, is manipulating the data into that data frame. Running the function is not hard. Anyone can do that. It's not even difficult at all. It's being able to manipulate these data structures in the correct format. So that's why you need to understand how these data frames work. And data frames are more powerful than matrices, as we said before, because you can have multiple types of data at the same time, which obviously complicates things, but it gives you much more rich, comprehensive data to be able to compare. So once again, what is a vector? What do we talk about? Vector are just, what's a data frame? Just a combination of features, right? Well, the features here are the vectors. So I basically have a feature vector, student names, character vector. I have another feature vector of the ages. Then I have grades, past. These are all just vectors, right? They're all vectors. Character, numeric, logical, right? And I'm going to put these together. And remember, the orders, when you're building these things like this, the order is extremely important. Like Alice has to go with these 3 values in the front. Bob has to go with the second ones. It's not going to find its way to the right one. You have to have them in order the right way, right? So one way you can build a data frame is data.frame. And just like you had list, remember? Now it's data.frame. Just like you had list and matrix, now you have data.frame. And you basically just now we've already named these vectors, right? So we basically just put the vectors here, kind of like the list, right? Our first vector is going to be called name, and we'll make it equal to student names. Our fourth one's called past. We'll make it equal to the name of past. So then we have our data frame with our 4 different vectors. And we'll call that data frame here, and here's we see it here. And notice here that we don't have row names. So if you don't have row names, they're just numeric 1 to whatever, right? What you'll often see is you will move this first column, name, over to name these rows. And that would make much more sense, because then the person's name would be the observation, and the 3 other feature vectors would be, annotating that observation, right? But you need to see it both ways because it's different. And maybe name should be a feature, the way that people are looking at the data here. So anyway, here we have 4 feature vectors, and they're basically all Columbine together. So once again, these are just 4 vectors put together. So another way I can do it is, alternatively, I can just say as.data.frame. So anytime you want to just throw things together and make a data frame, just throw it as.dataframe in front. I'm going to Columbine all those vectors. Remember, student name, age, grades, passed, they're all just like these columns of vectors, and I'm just putting them together, right? Sticking them together. So I'm basically just Columbining them all together, and I'm going to rename the top here. It looks like the same thing. I got the same thing here. Same thing, doing well. And then we can check the structure. So before we use that class variable to be able to check like if things were numeric or character or something like that. You can also use this string for a matrix as well, but it's really basically for, the string is basically for data frames. So class, you can use it for data types. Structure you're going to use for data frame. And maybe what you get here when you run structure on our data frame is we see 4 observations, right? 4 variables, 4 observations of 4 variables. So we have 1, 2, 3, 4 observations of 4 variables. We have our 4 vectors and with their class, right? Character, numeric, logic. And you see characters in quotes. And let's look at our V2 one, the one I made myself. Looks very similar, right? One problem is everything's character vector now. So I didn't really tell them what I should have said what they should be when I put them together. So this made them all character vectors, which now these aren't numbers. They're now characters. It's treating 21 like it's a word, right? So this would not work if I was running a function that needed that to be numeric. So really what I can do is, there's one trick I can use, I can show you, is that you really need to, if you're gonna do it that way, and the thing is that's basically why that's basically, oops, I gotta name the things, right? They don't just come out of nowhere. All right, so what are we doing here? Let's name all our stuff, and then let's make the matrix like I did, right? And then let's run the structure on my matrix. Now we see the problem, right? So what we would have needed to do, that's why you use the data function, right? Data frame structure. It sees these values and it corrects that first, and that's why you're used. But what you could have done is something like, you could have added as dot numeric, let's say, for ages. It just wants to know what it should be, right? If you do it now, oops. I think this should do it, right? I don't know why. So I guess you can't do it that. Let's ask that numeric. I guess you need to do it first. I guess we're already kind of defining it. But what you can do, though, a better way of doing it, I guess you could have said, you could have pulled up that actual value in the matrix. This is live coding, so nothing's perfect, right? So you could have pulled up that value here, right? And that would give you your deals, and then you could have changed it maybe there. Let's see, oops. As dot numeric. You gotta spell it right? Numeric. Ah, see, it tells me now, right? There we go. Now they're numeric, right? And if you look at the class, of that, you now see, ooh. sorry. If you do the class of that, now you're getting numeric, right? So you can just basically, you can fix that and assign it back in the matrix later. But don't worry about how to do that. I'm just basically showing you that if you don't use the function, you're not going to get it. So really just be aware of that. The point is, whenever you put together and make a matrix, be aware of what these values are, and you can always go back and change them. It's not a problem. It's very easy, but you just need to know what they are and be able aware to check out, what the values are and be able to fix them. But we'll worry about fixing them later. The important thing is to know that there are differences and there are problems that arise, right? So how else can you work with data frames? What are some other functions that work with data frames? Head is a very important one. So we have the student's matrix. We can run the head of that to get with a 2 here to get the first 2 rows. So we're getting all the columns, but just the first 2 rows, tail, the last 2. If you don't have a number, it's a default of 6. And this is really important just to get a glimpse of the data to make sure everything is correct. This is very important. You can imagine you have 10,000 rows of genomic data. You don't want to look at all that at once. It's too hard. This is the way you can just pull up a couple rows, see what's up. And often you'll sort things and you only want the top values anyway. So it's a way of seeing the bottom and the top there. If you want the number of rows, number of columns, these are kind of functions that will do that for you. The dimensions of the matrix. Once again, accessing columns just like before. It's no different. We see this is just like they're like a list under the data frame, right? So you can just type the name of the data frame, $, and the name of the vector. You get the name of the vector, right? Just like before. You can see here if we do let's use the right one, the student's one, right? You can call up. Oops. Well, since I haven't done it, it's not letting me. But we can use mine, and you can see you can call up the different ones, and you can also call up, a certain value. So I wanted the age vector, which is this vector, and I wanted the third value, which is 20, right? So it's the same thing. They're just vectors, right? So you just subset that vector. Grab that vector by calling the $, students.name. All I'm doing is just making a vector. I have that vector now. And if I want to subset that vector, how do we subset vectors? I bracket the number, right? So it's just a bunch of vectors stuck together, right? You can also use, the name of it to get the different thing. Too complicated. Just use the $, right? But you can, because sometimes you'll be filling this in with a label. If you imagine like a for loop, it would make sense. I want to call that each time a variable comes in there. I want to call that one. So that would make sense then. And if you want to call that, this is just like we subsetted the list before, right? You're just subsetting the list the same way. So you would just you would do double. So if you did 3 here, it's the third one, 1, 2, 3, right? So if you want to grade, you could double bracket a 3 or the name of it. It's the same exact way as the list. It's just a list of vectors. A data frame is a list of vectors that are columns, if you think about it. It's just often the same thing. Once again, if you want to look at just the second column, then say second column. You want all the rows. If you want to look just at the first row, just put the first row, number 1. We want all the columns, right? You can use, the sequences. Once again, these are just vectors you're putting in, basically. Once again, you're just putting vectors. This is just a vector of 1. Specific cells, 1, 3. That's going to give us, 1, 3, that 85, right? 85. Same thing. You can put in the name instead of actual number. I would always use the number unless you're pulling in variables, right? So how do we manipulate the matrix? How do we add a new column to a matrix? That could be definitely pretty useful, right? So if I want to add a new column, remember how they're just vectors of columns, right? So let's just make a new vector. So students, name, age, grade, pass, just make a new one. I'm going to call it letter grade. And I'm going to assign a vector of elements to that, right? Well, if I do that, by saying students, letter grade, assign vector, I'm sticking this letter grade column on the end in the same order I put it. It's not matching a certain way. It's just going in the same, or it better be in the right order. And it'll just stick in there. And this is no different than starting out with a letter grade equals at the beginning, right? We're just adding it in later. But it's not matching actually, but it's good to know, right? So now we have this full guy here. Well, what if we had two matrices and we wanted to merge them together, right? Like, for example, if we had a new column and we wanted to merge these matrices where they have the same names, but we want to add this year to another column. To do this, I would use the merge function. And I basically just say merge students year together, right? And what happens here is that the name column finds the name column and matches it exactly, right? And it pulls that along with it. So, and you notice these aren't in the same order as before. So they don't have to be in the same order. That's kind of the point. I want them to match. Imagine if you had a million rows, freaking rows, right? That's what you sound like when you have a million rows. You would put these together, you would match the names and the years. So if you notice here, I've merged it, and I basically have sliced out Deanna because she's not on this list. So now these have reoriented in the correct way, and they've matched. So Alice is junior, see Alice is junior here. So these have matched together. If you had millions of rows, you want to put them together, they're all different directions, all different things, and it's hard to be able to make them ascending or descending to sort them. This is a way you can just match them all really easy. And there's some more complicated ways of doing it. Let's say there was more than one values that matched. Maybe we had name, age, year. Then how do we know what to merge by? Well, we would say by equals, age then, or name then. But don't worry about that. We'll worry about that later. There's more complicated ways of joining. I just want you to know that you can merge things together even if you don't have all the variables. Now, we also could merge it and bring Diana along. And we would have Diana on the bottom here, but for year we'd have an MA value. It's not applicable, right? That's another way of doing it. So there's sometimes you want to pull in everybody and have NA values. Sometimes you want to pull in just the ones that actually have it. And I use this all the time in genomics. So it's a very important concept. You'll learn more about it later. And if you just want to kind of get a feel for what's going on in the matrix, for the data frame, you can do summary. And you can see here, it just kind of gives you a general summary of everything. It's just kind of trivial for most of these, except you have kind of a statistical distribution for the actual numeric ones. All right. So now we're getting pretty good. We got through our data frames. That's the most important thing. Remember, it's just a collection of vectors. Just feature column vectors. That's all R is. You make feature column vectors with rows as observations and run functions on them. That's R in a nutshell, right? And well, how do we work? Let's talk about working with built-in data sets. So you have these kind of built-in data sets in R, and they're really for practice. And the good thing about them is if you give someone code, that's all they need to pull them up. You don't have to give them a bunch of weird matrices that could be clean, have problems, or who knows. So the mount cars and iris ones are ones that are very common. You'll see these in tutorials all the time. There'll be a new function you're trying to learn. You'll look that up, and it will refer to these simple like built-in data sets when it shows you how to do them. So it's kind of good to be familiar with them, or at least how to pull them up. So basically you have this data function to pull in the data sets. You can run this to see all of them. And you can load the ones you want to use here. So I'm going to load this, and I'm going to look at the head, the first 6 values here. So let's just load that up here and see what we get. You notice it's up here, it's mount cars. And what you'll see now is they pulled in the rows as observations, which is the way you're really normally going to see this. You have your feature vectors, you have your rows as observations. These features are all associated with this Mazda RX-4, for example. And this is how you're normally going to do things, where you'll have like gene names, for example, and like RNA counts. That's the way a lot of times you will be able to work with things. And it's also ways to move these back and forth, which is it used to be really hard, but I have some functions that'll help you. We'll talk about that later. So this is be able just to pull up this data set. We can look at the structure of it again, and it's just going to be what? Columns of data features, right? So here's all our features, right? And they're just vertical columns, right? Vertical columns combined together of feature vectors. Once again, the summary kind of gives you a distribution of different things. You can look at the column names. If you typed in row names, you get the car names. You could also look at the iris data set. Iris data set is just looking at irises, which the petals are like the little tiny things in the middle of the flower. The sepals are more of the outer things, outer leaves. That's why they're bigger here. Species, just the type. And same as before, we can load them up and work with them. We can look at the dimensions, some different things. And they chose to not have row names here, right? Instead of row names, they have a actual column for their actual features, their observations, I mean. So there's two ways you can do it. Both are working their own ways. All right, so just a little quick quip about entering and exiting R Studio or R in general, right? So when you start up, you load up your R, and we already showed you how you started your file, new file, R script, whatever. But once you have the file, let's say we want to actually save that. Well, I can save that on desktop. Just go here, save as. Let's just say week 1 practice .r, right? And our desktop, we'll save it there. Now we have our R code saved. So everything in this over here is saved now, right? Well, what about all our functions here? What about all this environment? What if we don't want to lose this, right? So how do we save that? Well, we come back here and we see save image to r.data file, right? So the .r file is the code, .r data file is actually the environment, right? So let's just save that. And we can go over here. I'll show you this later and set the desktop as a working directory. Wherever you set your working directory is where all the files are going to go, all right? So we're going to save that. It's being weird. And if we go into our desktop, we can see over here, our desktop, we see our, it looks like I sent my my week 1 practice one somewhere else. I think, see, I didn't have it set, right? So my week 1 practice one, I think went in here. Let's just go back and you'll see. Oh, here we go. Desktop, I'm sorry. Desktop, our week 1, my week 1 practice, right? What am I doing here? Desktop, week 1 practice. Oh, I see. I set the working directory to week 1, right? So I'm getting lost. Bootcamp, week 1. So that's where my R data file is, right? A perfect example. You can actually move things here. I'll just move it back to the desktop. Move. Because that'll be easier for us to see when I open it, right? So here we go. So I have my week 1 practice.r file and week 1.r data file, right? So that gives me all of our R code and all of our environment, right? So when we pull it back up later, and I'll show you, we're able to pull that up. So you saw that change, but if I make a change to anything, you'll see it turns light blue here. That means it needs to be saved again, and then it's pulled back there. Another way you can save the environment, if you click here, save here, it would have done the same thing. Basically, it would have just ran the same code. You could have saved that R data file, and then when you want to load it, you use this code here, load basically the directory back to the R data file. So whenever you want to exist, so basically thinking about when you end an R session, it has all this saved data. You could have a bunch of plots here, a huge environment. If you just close this thing and be like, oh, I'm closing it, it's going to ask, do you want to save to .r data? And this is the system.r data file. There's no name to it. And basically, if you do that, when you open up R again, it'll pull everything back up the way you want it. And that's great, but sometimes what you do, and this is a mistake I made when I was a junior student, is I would have a lot of code and I had like 20 different bars here, bookmarks up here, tabs, and I have a huge environment. The environment we split up with several different projects. Sometimes it gets so big that when I tried to reload my R, it would get stuck. And I had to go in the command line, do all this weird stuff even to get it to load. So you don't want to get to there. Plus you want to have your environments specifically associated with the right code and projects, right? So what you want to do is, every time you start up a new R file, a new R script, or pull up a new R script for that project, right? Run and pull up your environment, work with it, and then save it back. So you just have a .r file and a .r data file only. associated. And there's Dart projects too, but I wouldn't worry about that right now. Just you want a .r and a .r data associated with each project, right? And when you want to leave, you can run this code, this remove list equals list. And this basically, if you do this, only do it when you're done. This gets you, we already saved this, so we're good. This will get rid of this entire environment right there. And there's another way to do it here with this little broom. This little broom would also delete off that as well too. But like I said, I think it's better to have it in the code actually. So you run the code, you do that, then that, and you're done, right? Then you want to do this dev off, right? This dev off. What this does, if you had a ton of a lot of plots, if you close R and reload it, it can have problems trying to reload those plots. So if you want to be able to save all your plots before you stop, right? So you'll save your code, your environment, separately save your plots, and then hit dev off. This will say this like this. It's not an error. That means that everything's off. Now we're good. Everything's closed off. Everything's clean. Let's close everything up, and let's get our studio. And now we don't save that because we've already saved it all. We want our data system file to be blank. So don't save. We're shut down, right? So let's restart. We'll pull up our RStudio, and then I'll show you the quick way to do it. Remember, there's an easy way and a hard way. We'll show you the easy way right now. You really should have new code that has your libraries and your ability to load in all this stuff itself, but we'll do the easy way. We can go to Files, our desktop. Remember that .r file we had, the weekly one practice? Pull that guy up. Now we have the .r file we used, and then let's look at our data file. We could open it this way and find it, or we can just, right there, or we could click on it, just click on it right there. Click on it right here. Yes. Now we pull up our environment. Now we're right back to where we started. We have all of our code, all of our environment. We don't even have to rerun the code. We have all the answers we want here. And then we can plot things again, rerun code, add things as we wish, right? So that's a really good way to, and then I lost my my HTML. So basically you can see how I did this. I pull up my R Markdown file, and I basically knit this into a HTML file. So we can look at that and finish up, and that's what I'm doing to get that file in the first place, right? Okay, so where are we at? Saving. So now we've actually saved, and we pulled it back up. So I think we have a good understanding of how to do that. Let's just run through a couple of practice exercises. So what I'm going to do each week is give you some easy practice exercises that we'll go through, and then some additional homework assignments you can go through later as well. So let's go through just a couple of practice exercises too, just to kind of rehash what we talked about. So the first exercise says, create a vector of temperatures in Celsius, basically do some maneuvering on it, and then basically subset run some functions, right? So first we want to create a vector. How do we create vectors, right? Assign to a variable, C combine the temperatures. So we've C, our temperatures. So now we have, a vector of temperatures. And then we can run different functions on it. We can run different actions on it, right? So here we want to convert to Fahrenheit. So we can use our vector. Remember how we can multiply by 2 or add 10? Well, now we'll just multiply by the conversion factor here, and we'll get our temperatures in Fahrenheit, right? Find temperatures above 20. Well, that's just subsetting, right? So we take our first guy, we use our brackets, right? And then we put our vector in of things above 20, because it needs to be above 20, right? So just temperatures above 20, vector, in our deal, we subset out those like that, right? The mean, easy, right? Just put the vector, run the mean function, you get the answer. Same for max and min, you just run the max and min on there. Simple as that, right? Exercise 2, we're talking about like creating our own data frame. So here, you don't have to do it this way, but we just throw it together. A simple one on books here. So we have the title of books, author, page numbers, and if they're fiction or not. So if you remember how we did data frames, we used the data.frame function and then just went through each vector that are the column vectors, if you remember. So data.frame, and then our 4 names of our actual vectors, and then the C combined, because we're actually making the vector, right? So these are character vectors, character vector, numeric vector, logical vector, right? So we've just added them all, we've just combined them all together. We made our data frame. We look at the structure, we see our data frame of 4 observations of 4 variables, and we just see our 4 variables here. And we see that there's character vectors, numerical logic, just like we thought, right? Well, we want to find books that are more than 300 pages. Here's kind of our final, what we're looking at here. It's just subsetting, just like before, right? So we put our books and then subset it. Subset in the brackets. We want all the columns, right? And we want just the guys that are over 300 in this column, the page column, right? So we look at the page column. This is a vector, right? And then we say it, we want just the values that are over 300. Well, these happen to all be over 300. So you're going to get all of them back here. It's kind of trivial, but you'll understand that you just want you want the rows that are over 300, which is all of them, and we want all the columns. So we really are getting everything back. Calculate the average number of pages. Well, we want to look at the average of this column, right? So let's just call the column books, pages, that's the column, run the mean function, we get the mean value. Show only fictions books. Now we haven't had this equal sign yet, but pretty simple here. We want just fiction books. So you can imagine we don't want this Sabian's book. So we can do books, brackets, rows, columns. We want all the columns because we want all the values. We just want to subset the fiction column, right? So call the fiction column, books, fiction. This is the vector, right? And let's just say of this vector of books, fiction, we only want values that are equal to true. And when we do inside function equals, we do double equals. So we're subsetting just the ones that are true. So 1, 3, and 4 row here, right? And you see here, we've left out the Sapiens. We pulled back this, just more subsetting. And finally, with the iris data set here, we can pull up the data set, column names, we saw before, number of observations, that's rows, the number of rows, mean of what? We want the mean of a sepal-link. Well, we just look at the sepal-link column. We pull up the sepal-link column, which is that vector, find the mean on it. We want only things that are setosa. Well, same things before. We want to subset this column for just those values. So we just subset this column, iris species, equal to setosa only, and we want all the columns, right? So we pull that up. Finally, with the flowers, same thing with the petal length. We look at the petal length, and we're subsetting this column, iris petal length, to a vector of those over 4, right? So we're just grabbing ones that are over 4. So it's going to grab all the species, just things over the petal length. It's just giving the head of the first 6 values. All right, so that kind of gives us, I think, an understanding of R in general, our basic data types, our basic data structures. So our data types are, right, numeric, character, logical. Our basic data types are list, matrix, data frames. This is kind of a simplistic way of looking at it now. And basically, we just put vectors together, right, into these complex structures like data frames, and then run different operations on them. That's all we're doing. And we just subset them out different ways we want to do it, and then just run the functions. So I've added some additional assignments here that I'd really like you to try on your own, where we're actually installing this tidyverse package, which we'll talk more about next week, and then just kind of try out some things. Programming cannot be learned by me lecturing you and you watching this video. You really need to try things out yourself. So please go into our studio and play around with this stuff. Now, I have all the answers as well, so if you get stuck, just look at the answer. But you really need to practice this yourself and try out some things for yourself. If it's just even making some vectors, making some data frames, doing some different indexing, substitutions, add a column, whatever, give it a try. You'll find that it really, really helps you out. And then finally, I've given you guys some additional resources, which I'll do each week. The first resource is these RStudio cheat sheets. And if you click on this link to basically the RStudio website, which is called Post It Now, they've bought them out, and you do contributed cheat sheets. You'll get 1 million of these things for all different things. And I'll give you these each week too and kind of tell you the ones to go to. But here, just base R, for example, creating vectors, reading and writing data, we'll do with that later. Making a list, making a matrix, data frames, the exact things we were just talking about all day, and a little more in depth too, because I didn't want to overload you with everything. But here's a good base R to look at, and then we'll have a tidyverse one. We'll have lots of these so you can be able to go through and check them out to be able to learn more stuff. So yeah, definitely do that. definitely check out those R Studio data sheets. Another thing is a great resource is this R for Data Science book. I guess I need to update this, click on this. Once you open it, you'll get the second edition. You can download this as a PDF or you can run it online. I think it's better in HTML because you can kind of click along the side here and, like we did, cut and paste code, go back to RStudio, go back and forth, try things out. See here, they're just filtering out, subsetting. But this is all using tidyverse and diplar, which is kind of basically a group of packages and functions that just make R easier to use in general. And it's made by Hadley Wickham and a different group of people. A big group of people they've put together these tidyverse functions, and it's still building, and it's really the best way, I think, to do things. ggplot2, everyone uses that, right? Well, everyone uses all these things, I think, in a simplistic manner. I really think next week we'll talk more about tidyverse, and this is just a repertoire of things. I think if you're going to learn R, learn it in this universe. So I think this book is extremely, extremely useful, and you should really think about giving your time to learning from it. And finally, the swirl. So swirl is a way where you can learn inside RStudio. And basically you can click on learn here, and basically gives you some instructions to install. It basically is just installing the swirl package and then loading the library and then calling up the courses. If you look at the step 5 here, install a course, click on course repository, you'll pull up the GitHub, and you'll see a list of all the different courses that they do here. And if you look along here, it'll give you some instructions. Here we go. Install swirl, load the library, and then install course. Here you go. So you put in the course name here, install course, run swirl. And basically, it's just going to pull up different exercises and different instructional things inside RStudio, inside R. So you'll get to work on it inside RStudio, and I think that gives you a good way to do some more practice as well, too, in a useful way. But I guess that's it for our first week of our Beginners Bootcamp. I hope I provided you with some just very basic foundational ideas about data structures, data types, and please look at the additional resources, look at the practice assignments, and give it a try. And I will see you guys back next workshop for the second week. Thank you very much for coming.